Hi everybody, this is part 1 of the lecture to accompany Chapter 9 in your textbook. Please read Chapter 9. It's critical that you understand this information. Okay, let's talk about categorical logic. Deductive reasoning is a major way that we come to conclusions, make decisions, and take particular actions. Most of us, however, don't particularly understand the deductive reasoning process well enough to determine how effectively we're using it. So it's possible we're coming to incorrect conclusions and maybe even making some poor decisions based on those conclusions. This chapter, along with Chapter 10, goes into some detail about deductive reasoning. We'll be doing things like Venn diagrams and truth tables to help you break down how exactly deduction works. For some people this is easy, but for others it can be frustrating. I understand. I feel the same way. This isn't a logic class or a philosophy class, so we won't be spending all semester on this, but it is critical that you have at least a basic understanding of deductive reasoning so that you can evaluate arguments. You'll need this skill as you go throughout life for things like understanding contracts or leases, applying to graduate school, law school, or medical school, and especially being able to see through fallacious reasoning and not be pulled in by the poor arguments of others. This chapter focuses on categorical logic, which is based on the inclusion and or exclusion of different categories of things. When we use the term category, we're talking about groups or classes of a population, different categories of objects, things, people, animals, etc. There are 4 basic categorical claims, each using different language to express the ways in which categories have things in common with other categories or not. The words no, some, or all are very important in categorical claims. The different claims are A claims, E claims, I claims, and O claims. An A claim is structured like this: all blank are blank. The example here, all German Shepherds are dogs, makes the claim that the entire population of the category of German Shepherds is part of the category labeled dogs. An E claim is the opposite of that. No blank are blank. The example here, no German Shepherds are aardvarks, makes the claim that none of those in the category of German Shepherds are members of the category of aardvarks. An I claim isn't quite as cut and dried as the first two. Some blank are blank. The example here, some politicians are lawyers, makes the claim that an undetermined number, more than 0 but less than all of them, of politicians also fit into the category of lawyers. Finally, an O claim, some blank are not blank. The example, some politicians are not criminals, claims that an indeterminate number, again more than 0 but less than all politicians, do not also belong to the category known as criminals. These claims are structured in a particular way known as standard form, and you'll need to learn to take the way we generally talk and translate those claims into this standard form. In standard form, the first blank is the subject term, and the second blank is the predicate term. Also, if you look at the A and I claims, you can see that they affirm that something is the case, so they're known as affirmative claims. The E and O claims say that something is not the case, so they are called negative claims. Each of the standard forms has its own visual illustration known as a Venn diagram. This is where you use overlapping circles to represent the ways in which different categories have things in common or not. When we use Venn diagrams to represent categorical claims, the following rules apply. Circles represent the classes or categories. A shaded area means that nothing, no members of that particular class or classes, if it's part of the overlap, exist in it. An X in an area means that at least one thing exists in that part. This logical relationship between things in claims assumes that there is at least one thing in a group, that it's not entirely empty. This is known as the existential assumption. An area that is blank does not mean it's empty. All it means is that we have no information about what is in that particular part of the category. So let's look at each of these claims. An A claim, all S are P, in this case, S stands for subject and P for predicate. So it says that all S are members not only of category S, but also are part of category P. So basically, all the members of category S are in that little overlap part, since they're also part of P, which leaves the rest of that circle empty. To illustrate this, that part for the circle S is filled solid. This means that part's empty. So let's replace the term S and P with actual things for illustration. Let's say that S stands for forks and P stands for utensils. So all forks are utensils. Now you can see that all the forks exist in that overlap of the circle and are also part of the circle that represents utensils in general. The E claim, no S RP, is represented here by the solid overlap. Remember, a solid color means that there's nothing of the thing you're referring to in that particular part of the diagram. So no S exists in the P category. Let's say in this case, S represents bunnies and P represents kitties. No bunnies are kitties. The illustration shows that the two categories have nothing in common. The I claim, some S are P, is illustrated here by placing an X in the overlap. This signifies that at least one, but not all, of the members of a category are also members of the other category. So some serial killers are women, might be illustrated by this. The X in the overlap shows that an indeterminate number of serial killers, at least one, also fit into the category of women. The O claim, some S are not P, is illustrated by an X in the main part of the circle for the S category. What this is saying is that at least one member of category S is not a member of category P. So some criminals are not violent people. Where S is criminals and P is violent people, the X would be in the non-overlapping part of the circle for the S category to show that an indeterminate number of criminals don't also fit into the category of violent people. So we'll be doing some of these Venn diagram exercises in class, so you'll get a little more practice on this. You've noticed that these categorical claims are very strictly worded. They have to be standardized so that you know exactly what's being claimed and where it fits. So while we're learning about categorical reasoning, we need to be able to take claims and change them from regular language into standard form. The language can tend to end up being kind of awkward and weird, but it's necessary. You need to translate a claim into its equivalent standard form, because the claims have to mean the exact same thing or it just won't work. Sometimes just a word or two needs to be changed. Other times it can get pretty complicated. We're going to look at 4 different ways that language can complicate the translating process and how to proceed. The word only can be confusing when you're trying to standardize a claim. If you see the sentence, only sophomores are eligible candidates, you might think it means all sophomores are eligible candidate, but that's not the same thing. Only doesn't mean all. It means that the only people who are eligible are sophomores, not that all sophomores are eligible. Some might not be. When you see the word only used by itself at the beginning of a claim, that means that what comes after it is the predicate, not the subject of the claim. So in order for it to be in proper standard form, you need to flip those terms around. So the correct form for this A claim is all eligible candidates are sophomores. That is equivalent, in other words, it means the same thing as the original statement. If you see the words the only, not just only, but it has a the in front of it, at the beginning of the claim, then it's in the right subject predicate order. The only people admitted are people over 21 can be translated to all people admitted are people over 21. When you just see the word only in a claim, you need to flip those terms around to make it correct. If it begins with the only, it's in the right order, but in either case you have an A claim, so it would need to end up as the structure all A are B. Sometimes claims that look like they are about one thing are actually about something else. For instance, I always get nervous when I take logic exams. Seems like the subject of the claim is about my nervousness, but it's not. It's about the times that I get nervous, which is different. So what the speaker is claiming is actually every time I take a logic exam, I get nervous, which can be translated to an A claim that's a little bit awkward, but fits. All times I take logic exams are times I get nervous. So it's all A, times I take logic exams, are B, times I get nervous. When a person makes claims about something always happening at a particular time, that's the subject, not what happens. The same thing with places. The claim, "It's not snowing anywhere in Massachusetts," translates to the E claim, "No place in Massachusetts is a place it is snowing." Yeah, it's a little bit awkward, but now it's in correct standard form. When you're making claims about individual things or people, you have to remember that categories are classes. So for purposes of translating into standard form, you need to assume that individual things or people are classes that have only one member. This means they can only be A claims or E claims because you can't have some of only one thing. So the claim "Aristotle is a rhetorician" translates to all people who are Aristotle are rhetoricians. San Diego is a border town translates to all towns that are San Diego are border towns. Again, it's a little awkward. However, once you become familiar with standardization, you can probably just leave the sentences in their original form as long as you understand what is the subject, what is the predicate, and which form it fits into. Mass nouns have to do with kinds of things. They're not quite classes or categories, so you need to treat them as examples of kinds of things. Most boiled okra is too disgusting to eat. Translates into the I claim, some examples of boiled okra are things that are too disgusting to eat. And home movies are as boring as dirt translates into all examples of home movies are things that are boring as dirt. Again, some of this is kind of odd, but the whole point of it is to be able to put claims into standard form so that you can go ahead and analyze the argument. The square of opposition is a way to see the logical relationships between claims that have the same subject and predicate. This logical relationship between things and claims assumes that there is at least one thing in a group, that it's not empty, and again, this is known as the existential assumption. The square has the A and E claims across the top, which are the all or no claims, and the I and O claims across the bottom, which are the some are and some are not. The A and E claims across the top of the square from one another are contrary claims. They can both be false, but they cannot both be true. So the examples here of an A claim, "All grapes are purple," and an E claim, "No grapes are purple," those we know to both be false. They can't both be true, but they are both false in this case. The I and O claims across the bottom of the square from each other are subcontrary claims. They can both be true, but they cannot both be false. And so the example here, "Some grapes are purple, some grapes are not purple." Now those are both true. And the A and O claims and the E and I claims, which are at opposite diagonal corners from each other, respectively, are contradictory claims. They can never have the same truth values. So if you know for sure the truth or falsity of a claim, you can infer the truth or falseness of other claims using the same subject and predicate. And we'll also be doing some exercises using this technique in class. This is the end of part 1. Please move on to part 2.